Hi, so again, this is Mr. Ford, and this is part 2 of transformations. So yesterday, or last video, we did translations. This time, we're going to be working on rotations. So I've already set up my Cartesian plane. I have my x-axis and my y-axis. Label those. And in the corners of the 4 quadrants, starting with quadrant 1, I'm going to write down my little cheat marks so that I can remember when I see certain points where those need to go. Okay, so rotations. Start with a different color, and I'm just going to plot out a shape in 4 different points. We're going to start with a rectangle. And the reason we're going to start with a rectangle is because rectangles and squares all have 90-degree corners. I know that these are all 90 degrees. And we're going to label them. Today I'm going to label using the actual coordinates. 8, 6, 8, 11, 5, 6, 5, 11. Okay. Now, when we do a rotation, there are 2 different ways that you can rotate. You can either rotate along one of the points, one of the original coordinates, or you can also rotate from a center of rotation somewhere out on the grid. So for example, I could use the origin as my center of rotation and rotate the entire shape 90 degrees somewhere else. Because of the height that I'm at, my shape might not fit or be really close to the edge, looks like. But for now, we're going to start with making one of the 4 points our center of rotation. So your center of rotation is sort of the pivot that your shape is going to move it along. And we're going to use 5, 6. So I'm going to label that my center of rotation, or my COR. And the next thing I'm going to do is I'm going to label out my 4, if you want to think of them as cardinal points, my 4 main points of rotation that I might be asked to do. So we're going to start. I'm just going to draw my dotted line up this way. I'm going to do another one out this way. Another one out this way. Down this way. Okay. Now, since my shape is here, I'm going to start this off as being 0. 0 could be any of these, and you can fill them in depending on if you're going clockwise or counterclockwise, 90 degrees, 180 degrees, 270 degrees, or if we were going counterclockwise, 90 degrees, 180 degrees, 270 degrees. And we're going to start with a rotation 90 degrees counterclockwise. So we're going to rotate 90 degrees counterclockwise. Now the same as in a translation where all of the points move in the same direction and our shape doesn't change, in rotation all of our points rotate in the same direction, and our shape, the actual makeup of our shape, how long it is, how wide it is, does not change. So now, since I've already made my cardinal points, I know that this is 90 degrees. And if I wasn't sure, if I didn't have a grid, I could check this with a protractor, but I know that this is 90 degrees. And so I'm going to rotate my shape this way. counterclockwise. Now, the same way as we did our translations, I'm going to count the number of points that my shape is tall, and I know that it's 5 points tall, or 5 different places tall, and it's 3 wide. My center of rotation does not move. It can't suddenly end up over here, over here, over here. It has to stay in that spot. So I'm going to rotate this one down. And if this line was here at 0 degrees, then now this line is going to be here at 90. And if I know this is 5 tall, I'll use a different color. I'm going to use my ruler, and I'm going to count out 5. 1, 2, 3, 4, 5. Draw my line across. And then it used to be that this shape was 3 wide, but now, since this is my base, this is my width, I'm going to go up 3. 1, 2, 3. Draw a line there. It's hard to see because my pen is the same color as my y-axis. And then lastly, since this is a rectangle, I know that this is 3 up. This is 3 across. So whereas a translation, you are shifting the entire shape in the same orientation around to different parts of your grid, in a rotation, you're rotating the same shape. If you want to think of this almost like a box, you just flip the box on its side. And now I'm going to relabel my points. So 5, 6 does not change. It's my center of rotation. This point here, 8, 6, is now 5, 9. This point here, 5, 11, is now 0, 6. And 8, 11 is now 0, 9. And I can label both of these shapes, so we'll call this one rectangle 1, and this one rectangle 2, and in brackets, rotate 90 degrees counterclockwise. And so this is a rotation. Now we're going to rotate a triangle, and we're going to rotate an easier triangle. We're going to rotate a right triangle. So I'm going to put in some points down here. We're going to label them. So again, my x-axis is here. I start here, 8, 10. Now that we're down here, I know that this is going to be, sorry, I messed these up earlier. Oops. It's going to be 8, negative 10. This one here is going to be 4, negative 10. This is going to be 8, negative 5. All right, so we have our triangle. I know that this is a right angle, so I'm going to make it easy. This is going to be my center of rotation again, so I'm going to mark that. And this time we're going to rotate 180 degrees. And I'm not going to say clockwise or counterclockwise because I know 180 degrees is all the way around. And so it doesn't really matter whether I rotate this way or this way. I'll end up with the same. If you did see, say it said clockwise, then you would just draw an arrow showing that you rotated it clockwise, but your end result image should look the same. So just like we did last time, I'm going to create my cardinal lines centered on my center of rotation, and name this one 0. And I've been asked to bring this 180 degrees. So I know that 180 degrees forms a straight line, because on a protractor, if this is the center of your protractor and this is 0, 180 goes all the way around here. So put 90 degrees, 180 degrees, 270 degrees. So now this point here, my 8, -5, I'm going to rotate all the way around. And I can see that it's currently 1, 2, 3, 4, 5 points above my center of rotation. If I flip it all the way around, it's going to be 5 underneath my center of rotation. 1, 2, 3, 4, 5. Now, one of the issues that could possibly happen when you rotate 180 degrees is some people like to think of it as, oh, I'm just going to flip my shape over. But the problem is that your shape won't be in the correct rotation, because if we look here, this is on the left side, and if we were to rotate 90 degrees, this would come up and it would be on the top. And then if we rotate again and we rotate down to 180 degrees, it's here over on this side. Whereas if you flipped it, you'd be flipping it into this area here, and that would be incorrect. So we're going to bring this one around 180 degrees, and it started out 1, 2, 3, 4. So we're going to go 1, 2, 3, 4 from our center of rotation and redraw our shape. And then we're going to relabel. Again, our center of rotation doesn't change. It's still 8, -10. This one is now 8, -15. And this one is now 12, -10. So that's how we would rotate a triangle if it is a right triangle. But what if our center of rotation and our shape doesn't have an easy side or face on the axis? So here up in our rectangle, we had multiple sides, really, that were straight. They ran across the lines. And here again, we've got 2 that run across the lines out of 3. What if our shape doesn't do that? What if we have an irregular shape? So we're going to draw another shape over here. To make sure I don't make it too big. Quickly label this. So now our x-axis is up here, -7, -14. -4, -10. -8, -8. -5, -5. So here I have a shape that does not have a single side that lines up with my grid. Okay, all the points are in different areas. They're all over the place. I have no right angles to use. So what I'm going to do is I'm going to start off by drawing my cardinal points. And we're going to call this top point -5, 5. This is going to be our new center of rotation. So the same as I did everywhere else, I'm going to make my cardinal points off of my center of rotation. Bring in my ruler. You can see that my cardinal points actually go through my shape, and that's very important. So we're going to rotate this one just 90 degrees. And we're going to rotate it 90 degrees clockwise. So rotate 90 degrees clockwise. So I know I'm rotating this way. Well, what I'm going to do is the same as I did over here. I'm going to count the number of positions my center of rotation is from the other points. Now I know if this is my 0 line, so my 0 this time is over here, my 90 degrees is over here, my 180 degrees is over here, and my 270 degrees is over here. I know that this line is now going to become this line. So if I go down here, go 1, 2, 3, 4, 5 down, and 1 to the right, I get negative 410. So if I rotate this, and I do the same thing, I go down 1, 2, 3, 4, 5, and 1 to the right, I'm going to find my new point. It's a little bit difficult using the ruler on the coil book like this. And then I come back and I do the same thing for this second point. So I know this was 5, so I go 6, 7, 8, 9, and 2 to the left. It's going to fit on my page. Let's see. This is 5, 6, 7, 8, 9, and 2 to the left. Oh, just barely. And then starting from the center again, 1, 2, 3, 1, 2, 3 to the left. 1, 2, 3, 1, 2, 3 to the left. So because my center of rotation doesn't change, its position doesn't change, I'm able to recreate the shape, even though it's irregular, at a perfect 90-degree turn without any guesswork by rotating it based on the number of spaces on a straight line that I've created. This straight line isn't part of my shape. It's not part of my points, but it's something I can use. My cardinal points are something I can use for reference in determining where 90 degrees is. And then the last thing I'll do is I'll name all my points. So I've got negative 10, negative 6. The center of rotation doesn't change. I've got negative 8, negative 2. And lastly, this would be 12, 13, 14. So I've got negative 14, negative 3. And that has been how to do transformations, rotations. So part 2, rotations. We rotated square shape or a rectangular shape with 90-degree angles. We rotated a right triangle, so a triangle with a right angle, and we rotated an irregular shape as well.